increases complexity to fit the data too well. Okay. So, and it's not going to. So now what you do is some people train their data like this that they try to use more parameters. Okay, so they keep increasing the parameters till they are able to explain every kind of image and every kind of data. But what happens is that is so badly overfitted that that may not fit the real world data. And what the purpose of designing deep learning models or the database is basically this: that we want them to work in the real world. We want that if I'm inputting some data with my phone in an app which uses a deep learning method, it should be able to give me a proper prediction or proper reply that very moment. Like we want Siri to be actually very accurate. We want Google Assistant to be accurate. We want to ask them questions and we want answer from them. So what Siri is doing is it has lower layers which have been pre-trained. So there are some catchphrases that it is able to identify. Like I say alarm clock, and I say set an alarm. So that those words are already there. It has learned due to training. It has learned that set an alarm. What set an alarm should trigger in your phone. Okay. Some it doesn't identify because it has not yet learned. But if you keep saying some things now in the new upgraded versions, if you keep teaching it something, it does learn, right? So it is also learning, basically learning. So we want to come up with a function which is able to predict an observation given the X. Okay, so this is our data space. This is our data space. This is a function that we are using, and these are our data points. So how is our model going to fit? Okay, so we are tuning our parameters and we want them to fit. So this is the easiest. This is one order fit, means it's just one line and it's able to explain some of the data points. But we are not able to get the answer for these data points. How will it explain these data points? So what we do is we increase the parameters and then we get a 3-order fit. So we say, oh wow, now we have more data points. Now it's closer. Now it will be able to explain this also, and to extend this also. So then we think, okay, fine, it's wonderful. Let's increase the order fit now again. Let's try to increase the parameters and fit every data point. So this fits every data point, but it looks very ridiculous because you cannot keep increasing parameters for every set of data. And if you're going to do that, then your model is not going to work in the real world because you cannot have a massive cluster or a cloud to compute this. If I'm looking to do this computation on my phone, I cannot do it like this because this will consume massive amount of processing power because I'm increasing the parameters. And what are parameters doing? They're learning. So when you're learning, you're training, you're again and again processing something, the signals are going again and again. It is a very tough process. And this is what we exactly call as overfitting. We say the model is overfitting. It's trying to fit every data. And it is saying that it is explaining every data, but then it won't work on any new data because it has trained itself only on one set of data and it won't work on any new data. So that is the problem with overfitting. When we increase parameters to make those fits, it increases the error rate also.
Good afternoon, ma'am.
Good afternoon.
Ma'am, actually the screen has been stuck at a certain slide and we are not been, whatever the current is going on, we can't even get it. It's only the audio which we are getting.
Oh, okay. I don't know why it's happening, but I'll try to do it again.
Okay, ma'am. Thank you. Sir, I also, sent a video clip from last 15 minutes or 10 minutes. The screen is stuck on a slide. If you check the video on the WhatsApp group, you can see that.
Can you see now?
Yes, ma'am. Now we are getting the overfitting, the same the thing you were explaining.
Okay, now is the slide moving?
Still on overfitting, ma'am. If you try to change it, then we can get is it moving or not.
Yeah, I'm changing it, but I think it's not moving for you. Okay.
Okay.
Let me try to
There's
do
some
it
technical.
from Okay, now I think it is visible.
Yeah, it's okay.
Okay, now
Yeah, it's okay.
Yeah. Okay, so I was talking about
Yes, ma'am. Now
overfitting.
it's okay. Now it's okay.
Okay.
Thank you, ma'am.
Oh, thank you. So we want the best fit, but we don't want to overfit, right? And for this purpose, this is the very sense of why you should not just train your model and put it in the real world, because then it won't work. It is fitted to one order, one way. Okay. So what I was discussing was that this is a one order fit here. Okay, and then we increased the parameter, so it fitted a bit more, but then we went for the overkill and we did an 8 order fit. So it fit the model, but there is no guarantee still that it will work on the real world data. So what I have to do is even if your data is complex, we need a model that is flexible enough to adapt to the real world situations, to the applicable layer. Okay, and so we have to think of how our model is going to work well in the real world. This purpose, we need to generalize our models. So we need to make it go through a data that it has not learned anything on that data, right? It is just being put on that data, and we are just looking for what accuracy it can give, right? So we have a training set data, then we use another real world data, which we have not trained earlier, and so that is how we can get the best model. But what happens is that we can't keep looking for too much of new real world data, then there will be no end to it. Because if I'm trying to train it on cars, then there are just too many cars and too many shapes, too many things. So I have to take one database and I have to train on it. But it's not important that something from the other world will come and then I can test my data on that and that will work. That is also not possible. Some customization is required. So if I'm looking at some cars, that it can be a specific region where I want to see how it works, or one kind of car like one i10 or something. So what we do is we take one database. So we try to take a huge database, but we try to have some similarity in that data. Okay, so like cancer cells, so there are cancer cells in that, but it's a huge database. It has data from all parts of the world. So what we do is we split this database that we already had into a training database, a testing database, and a validation data. So we split it into 3. So now the question is, okay, training data is there. So what the testing will help in is, this is done everywhere and we don't train it. So what we do is we first only separate our data before putting it into the model. We first only separate the data that will be put in the test set. Then we use the training data that we have taken, we train it on the model, and the model, we fine tune the parameters and the model gives predictions. Then we take the same data, same model, and we put this test set. We put this data in the model now, but we are not going to make the model learn. We are not fine tuning anything. We are just saying, you just classify now. Whatever you've learned, use that knowledge and just classify now. So it will never be used to learn any or fit any parameters. And it can even evaluate performance of network on the test set, right? So this is just like, running a new experiment, but this test set should only be used once. It's not that you keep running it over and over again, because obviously there is some kind of stochasticity in the model also. It might want to learn in different ways. So reusing this test set, which will again add a bias because it will learn towards one side only. So what we do is to reduce that bias, to not rerun the model over and over again to check again, we use another set which is called validation. So we have a training set, we have an output from the training set, then we run it on the test set, we get an output there. And there's another validation set with which what we can do is we can compare. We'll be able to compare our model. And so we can do this. Test set, we only run once. In validation, it's up to you whether you want to use it repeatedly or not. And then you have 3 outcomes. You have 3 types of outcomes, and then you will be able to see how well it is doing. If it's not doing well, you can retrain the model, and it will help you. So that is how mostly people, what they do is they just use training and test. Validation is an option, but only if you want to do it. But it's like most of the people who work in developers say that they don't have enough data to do that much classification also for some tasks, not all, but for some tasks they don't have that much data. So they do with training and test set only. But if you have a validation set, you can create it. It's wonderful. Because what happens is, so you're testing, you tested it. So what validation is helping you is when you're running on it, you have 2 examples, you have 2 outcomes here, which are actually giving you the result and telling you how your model is doing. So it's not doing well, you can just refine the model. Validation data set, you can just run it 2-3 times and see whether it's working or not working. And then you can refine the model, retrain it, and work your way out. So that's the basically way to get over the overfitting part, which I was trying to explain. So these are some questions, but mostly we learn. How do we learn the network? We learn it through parameters. How can we mathematically set up our learning goals by, using the equations that we've done? Learning is basically optimizing. You are improving the performance, right? So this is the equation that we're using for learning, basically. Now, what happens is, while your arguments, while this B parameter we are learning is, you're trying to optimize also. Okay, so we are saying we are trying to minimize the losses, right? So there's an algorithm which will help us to minimize the loss more efficiently than normally other functions. So we use gradient descent, is basically used to optimize the parameter by reducing the loss that we were calculating, right? So what happens is, okay, so let's say we are in a plane. So we have this function that we are using, okay, the function that we're using to calculate parameters, and then this is what we are trying to minimize. So what happens is, here's a data point, okay, and okay, so we're looking at this current point, and we want to go towards the minimum, right? We want to go towards the minimum. So if we go here, we can even go back. It's like that. So we want efficiently a data point to stay here so that we can reach a minimum. Okay, like this. So what gradient descent, the name descent means it's going down. We look at the slope of our curve. Okay, so this slope is here, and we want to move to the left side, basically. So we want to see where should the algorithm move so that it is able to move towards reach this minima, right? So it has to, the slope is this, so it should go here, and then it can reach the lowest point more efficiently, like here. So if we move towards this side, okay, then it will reach a lower point more efficiently, okay? So then this is what we call as gradient. If you've gone through mathematics, this is a gradient, right? It is, gradient is like taking a bite out of the whole food, basically. So this is how your data point will move if you move like this. So if I move towards the left side, I take this gradient, then it will reach the minima, move faster. It's just a visualization point. It's a mathematical, it is presented mathematically in this form. So that's why I'm trying to use this kind of visualization to just make you imagine how a gradient descent is reached, basically. So then this is how it travels. We keep taking the gradient, calculating the gradient here, and this is how the data point moves towards minima. Okay, so then we are trying to minimize B, okay? We are trying to minimize B through the function that we've used earlier. So then we start with B naught or some value, some initialization, and then we move down. And so we keep updating it. BK to BK plus 1 is means the new state that we get when this moves here. That is a new state that we are getting upon taking the gradient, calculating the gradient. Okay. So this is how the procedure works. So we take a derivative of multiple parameters. Okay, so that is how we calculate the slope. And in the direction of negative gradient, we say it is a negative gradient direction. Okay, with the step size of alpha k. So we say we take this step size that we take is alpha k. Okay, alpha k, and then we keep updating it like this. Okay, so k plus 1 is the new state that is achieved from the previous state by taking the gradient. And unless and until it converges, we keep calculating it. Now, but the problem here is this algorithm actually looks at every single data point. So it's going to pick on all the data points, all the data that you have in your data set, and then going to move. So it's not scalable, means if you have a very large database and that has a lot of data points, the algorithm will keep getting stuck. It will keep moving here and there only. And it won't reach the minima very soon, and it will get stuck in some global minima that we look at. So what can we do? In reality, the data is very complex. Data points are very large. And you cannot keep looking at one data to minimize the loss of one data point and then think about predicting the other. Then it will take you a lot of time. So what we are trying to do is that instead of, because it looks at one data point, then it moves the point, then it takes a gradient again on that position, and then it moves that data point towards local minima. So it's focusing too much on one data point only. So what we are saying is, let's try to be stochastic. Let's not go after one data point only all the time. Let's take a gradient over all the data points. So what stochastic gradient descent does is, it's similar to gradient descent, but it picks the data points randomly. So earlier we were only after this data point. We took one data point at a time and we were looking where it's going here and there. So, but in stochastic gradient descent, what we do is, we have a data points, so it will randomly keep picking the data points. Some data points must be here, some maybe closer to minimum. So it will randomly pick those data points and keep taking their gradient to reach the minimum. If the previous gradient takes it towards minima, it will follow that. If it doesn't take towards minima, it will change the data point and it will take somewhere else, in some other data point. It will pick the data points randomly. So you must be thinking, why should this work? This should work because data is often redundant. Redundant means there is a lot of repetition in data. Okay, so it's not important that there is only 1 3 in the data set, there is only 1 1 in the data set. Okay, and if you're trying to fit every image and every data point, then it will take like a lot of time, consume a lot of resources, and in the fast moving world, we need to do everything quick. So it has 60,000 images if you take the MNIST data set here. But if you look closely, it only has 10 types of images. Means there are only 0 to 9. Okay, so there are only 10 types, but the images are 60,000. Okay, so there is redundancy. It's not that all 7s are looking very different from each other. They're looking very close also. Okay, so even if I randomly pick this 7 and this 7 and this 7, it should not make much difference in that. So if I'm randomly picking data points which are giving me a best gradient to move towards the minimizing the losses, then I will be better off here with stochastic gradient descent. So stochastic gradient descent is actually used more widely than the gradient descent for this purpose only. If your data set is sparse, means it has less values, then gradient descent will do well. But if you are working with the stochastic gradient descent, means if you have large database, you have a lot of data points, especially if your data is redundant, there are similar images of one thing, like a cancer image, which has a lot of similarity, obviously, then stochastic gradient descent will also give you the best value and very fast. It will go down very, very fast because it's not dependent on one data point, it's randomly picking on data points. So this is actually just an indication of the stochastic gradient descent gradient that we are taking. So this is where we are applying the gradient descent. So that is going to help it minimize the losses, help it learn, and classify the data that we are looking at. So this is what I told you, that the advantages are there, that stochastic gradient descent will be able to update many more times than the gradient descent, and it will get to the solution quickly, and it will also help to scale to big data. We are looking at that through this model also, through this algorithm, to big data. Okay, so this is another application of deep learning for image analysis, for the eye analysis. This is, if you see, this is a healthy retina here. So this, if you see, it's a little darker here, right? And that is how it is seen. An unhealthy retina looks very bright, but it's unhealthy. It's not healthy. So that is how you have to classify. So this is a classification task. Okay. So you want to know which is a healthy retina, which is an unhealthy retina. So what happened was in their paper, which the reference is given here, and what they did was Gulshan and all these scientists, what did they do was they classified sensitivity and specificity. Means the number of true positives. So true positives means that these are the true positives because they don't have any negative here, no darker spot here, but it is an unhealthy retina. So they classified these images based upon sensitivity and specificity. Specific means the true negatives. So it's the reverse. If the true positives are more, that means the retina is damaged, unhealthy. And if it has true negatives, then that means that it's a healthy retina. So basically, this is something medical, but what the point I'm trying to make is that the high specificity, if you see these data points, these are actually doctors who were able to identify the images, classify them in sensitivity and specificity. And this big line that you are seeing here going across is actually the deep learning model that was able to predict this much faster and more accurately. So it was able to differentiate between the healthy and unhealthy retina much faster than most of the doctors could. These are just doctors who did well, who were able to predict the retina looking at the images without the model. But this line indicates that the model was able to surpass the doctors very well. And so it's been seen as a as a boon in diabetic retinopathy. Diabetic retinopathy means people who have diabetes, their retina gets affected, their vision gets affected. And so the images that were used here in this paper and in this database were basically taken from there. So this is how it works. Then this is another application of deep learning. So this is a TSA screening. If you see the travel screening on airports, so this is how the images. So most of the data when you all must have gone to the airport. So when you send your luggage in that screening thing, so it shows if there is any object like this gun or anything, it shows on the screen, right? So that means there are fundamental layers which it has already learned, and your test set or your the luggage that is going inside, and if it has anything doubtful, it is able to capture that because obviously the shape and image is already there, and it is able to differentiate between the other works than this. So it is also being now used in TSA screen. Earlier there was just an object detection or something they were using. Apart from this, there's also a concept of 3D surfaces, surface meshes. What happens is from this image that you see that your people are playing, it is converted into this 3D image, and the 3D image is also in the form of meshes. So these are the data points that are created from the real-time footage. So what this helps is that this helps in your 3D games. A lot of 3D games that you play are actually, look very real when you use those virtual reality equipments or the virtual reality goggles or something, 3D goggles or something. So there you are able to, which we call as augmented reality also, where you're playing the game inside that your phone, but with the help of that equipment, you feel you are already inside a forest or in a battlefield or something like that. That also uses this concept. This is a mesh creation, which is a data point. Okay, and these are then separated from the original footage, and they can be used in some other footage. So I can take a Shimla Mall Road and I can put these people there, and then I can reconstruct them into this form. And so you will feel that these people are roaming on the Mall Road and not in this ground here. So the creation of artificial images or artificial reality is also possible through deep learning. Before I get to activation function, what I want to explain here is some of the other applications are also that it is also being used to predict earthquakes. It's under research. This part is whether we can use the sensor data that is used, the seismograph data, and make the model learn so that it is able to predict the earthquakes or not. It's also being used in finance. In finance, obviously, there's a lot of data in finance, transactions, everything, and whether we will be able to catch, whether we can predict some kind of investments there also. It's also being used to detect phishing also in our banks and other places where, there are certain set of transactions in case the transactions look doubtful, whether an account was active or it was. That is how actually these people, how they are able to figure out whether your bank account is lying dormant. There is no transaction has happened there. They're able to detect it, and then some of them are even so good. Those hackers, they call you and they tell you that your account is lying dormant and you should do something and this and that, and So a lot of people are actually using phishing attacks also. They make the model learn through the activity the network activity, and they are able to do this. So this is also being used in Internet of Things. IoT means automation. Basically, a lot of sensors and a lot of these LEDs and these things are used to make smaller applications. Even if you want to create a garbage segregator, you can make that model learn. You can just use a bit of LEDs and connect them, connect the sensors, use that sensor data. And because wherever you use sensors, they generate a lot of data. Okay, so the sensor data can also be used to learn, make the model learn, and automate some kind of a process. If you want to even create an apple segregator, if you want to, like our orchardists, they classify the apples in different sizes, right? Some big variety is put into separate boxes, and the smaller ones are put into other boxes. You can even automate that based upon some kind of sensor data, or or even calculating the average output from the orchard. But that's another story. That is something, the small level projects that we can think of giving to our students, and these things they can create on their own. These are lab projects which could be encouraged. And then there's driving assistance. Driving assistance is also based upon the coordinates. So the input data there are the coordinates of the road, coordinates of the city. It can take real-time coordinates also from Google Maps and others, and redirect you. So Google Maps are themselves an example of good learning, because they learn where there's traffic and then they will redirect you. But there's a possibility that it doesn't do good predictions in the hilly area because it's not able to understand the terrain well, but still. So these are some of the applications, and there's automatic handwriting also is there. If you attach a sensor to your pen and you write and you give a lot of data by writing in your handwriting, your machine will be able to understand what is your handwriting. So if I'll show my model my handwriting on paper, it will recognize that it has been written by me or it has not been written by me. So these are deep learning applications. They are used with other machine learning applications also and other fields also. Activation function, actually I just thought that we should touch upon it because this is the building block. So activation functions basically, so when the image is being extracted and you're looking at those filters actually have these activation functions, the filters that we saw. And they are built up of neural nets. So they have input, which is being fed, and these weights are being calculated, and then it gives you a value, which is put to the function values. So this is a linear activation, means the value is minimum and maximum, and it's equally distributed. Both the parameters, the function value and the parameter value, increases at the same time, at the same level. But this is idealistic. Actual data is very noisy, so you may not have a linear activation, which is why we switched from logistic regression to the multilayer perceptrons also. So if you use any function here that we are using, sigmoidal, tanh, in different models you use different functions. So it will give you a minima and a maxima. Okay, but these planes are not good. They are not, your value should remain here, because that means the model is not learning. When you are going up or you're going down, that means there's some data is not there, or the data, or you are learning the feature. But if this is more often in your model, then that means the model is not learning. It's just there. It's not learning anything new. So the problem with this kind of linear activation was this. That's why we switched to the non-linear. A better function to predict that is rectified linear unit, which is also called ReLU in short. And what it does, it will be able to catch the lower predictions and the upper predictions well. So it minimizes these values which are relevant, and it is able to amplify your signal or your optimization. don't know how much time we left, but okay, I'll just give you an overview of pooling. Pooling means sometimes we have a lot of connected layers, lot of weights, and a lot of those parameters and a lot of data values. So the network becomes very, very large. Okay. And so we don't want that much of data at every level, because then computational requirement will also increase. So we start pooling at some level. So it also helps us to combat overfitting. And so what happens is, if this is just an example, so if you have this feature map and you have these features, so you may not require all these feature values. You might just want one high feature value, which is enough to explain the data or the database. So you can use a filter which is not made up of these 4 values, but just one value, the maximum of these values. And you can use them at a higher level, and this will help you in making the predictions for very, very large databases. So these are the layers. These are advanced models where you have multiple layers. So what happens is, when we have a lot of databases, lot of information at one level, we try to pick the best out and we try to pool them. So when that information again starts increasing, because we are applying convolution layers at different levels to refine different kind of data. And so then we again put a pooling layer so that we can get a robust information and a concise information and fully connected readouted when all these cells are connected to all the filters here. That is a fully connected readout. And if I could just give you an insight on word vectors, word processing, which we also call as natural language processing. Okay. So basic crux of the word vector is this, that so this is just a word example, but like the cities are supposed to be more clear. Okay, so if Delhi will be more closer to Kolkata than to someplace New York or something, right? So we look in our database when we are dealing with words or documents. There are words that are going to be close by. Like if it's written about me, then my name will come 2-3 times, and it might be closer only. If somebody is reading my biodata or somebody is reading something about me, so my name will come a couple of times and it will be close. So I can use that similarity to extract the data and do the document analysis. Okay. And it's also possible that in a document, when you're reading about something that which is written at the end may not be connected to the one that is closer. So in a database, the data points, the words are also spread like this. Okay, so in the first paragraph, I might talk about machine learning, machine learning, machine learning. In the second, I will go to deep, deep, deep. And in the third, I might talk about some history or something. So that means the vicinity of similar words is different in different parts, right? So each vocabulary is mapped to a point in 2D space. And if 2 words are close, they will be more related. So if they are far away, then they will be dissimilar. There's high possibility. So how do we do the word mapping then? So we are just calling them longitude and latitude because I give that this world example here. But these are just words, right? So we are looking at lawyer, attorney, penguin, apple. And we are seeing in a document, if we have a document in the form of a matrix, okay, this is a document. So it's possible that a word is here, then a word is here, here. But more similarity will be in words which are here. This is a word database, right? So it's, see here. So there's a police and these kind of suspect, arrest, witness, victim. These are the words that are going to be very close to each other. So they can be captured well. So what we have to do is, the numbers are easier to extract, but words are not actually very good for extraction. So we used to create filters, right? So pixels also we extracted in the form of some values only. and some other data also, coordinates or numbers. So even though words are very closely related, so if I read the document, then I'll be able to find out. But for the computational machine, because the writing, spellings, there's a lot of things, lot of aspects are there. So we would like to compute, we would like to do the word processing in the form of numbers only by extracting the numbers. So what I was trying to do here was, I was trying to look at the frequency of the word lawyer, okay, and trying to make a vocabulary, trying to draw a vocabulary of these words. How many, third is penguin, and what kind of value is associated with it, the frequency, or, you know, how many times is it visible actually here. So vocabulary of words means how many times it was, each word was visible in the document, and latitude, longitude means how far they were from each other or something like that. Okay, so here, okay, so this is called word mapping. Okay, word mapping means we are trying to convert our words into some form of numbers which we can actually use to process further. Okay, so we want to create a map of them. We want to map, like 5 is related to penguin, or 15 is related to some lawyer, any word. So we're trying to create a word map. So we also call them vectors here, okay, because we are mapping them. That means it has a direction. So it is also called vector, word vector. And so word mapping is basically trying to find out the location or the frequency, and but mapping them in terms of numbers. So it's also called word embedding. We also call it word embedding. And this is how, if you see the feature space, the features that we extract must be like this, like cake, dessert. So car is not related to it, school, you know. So these are distant words. So when we look for word, word means we're looking at the word, we are going to classify its occurrences in terms of numbers. Okay, so there are V words in vocabulary. We are saying that this document is actually an office document, and that office is that of, say, Ayush Ministry of Ayush. Or there are some Ayurvedic words or something related. So we can make a database, we can classify, and we say, okay, these are the words that are most likely to occur. You know, there's some medicine like mulethi, or some, you know, some turmeric or something. And then once we classified those words, you know, because we're looking at specific documents, so we classified the words. The word will have to be mapped into some kind of coded numbers to create a vocabulary code book. Okay, because we want to process this information. So we're looking at the M-dimensional, and we are mapping these words into code books. So these code books are then created. This code book is then used to do the natural language processing and using them. And we also try to look at how close the words are with each other. And we can see those relationships when after this we put them through layers and try to extract features like we saw earlier, the correlation that we were trying to find in shapes and in those motifs pictures, you know. So we'll try to find out the close proximity of those words also by using this vocabulary. This is also called word to vec, because you're mapping a word to a vector and giving it some dimension or some values. You know, you're saying this 3, 4, 5, 6. This is the coding where you will be able to see the lawyer closely. So these are the locations that you have traced out of where the words were very similar or close to each other, and you're further coding it in multiple layers. You're looking for the combination of words. First, you were looking for words, you extracted that information. Then you look for combination of words, the proximity of words. So this is called word to vec transformation. You're creating a vector from the words. So this is means beginning of sentence. This is the end of sentence. So this is how closely you want a sentence to be. So assume that we've already learned one from before, and now we are looking at the relations, not just the words. So then we can see the beginning and the end. Okay, and we can again map this into further top layers of our neural network, and this will keep on building and until we are able to find the relationships. So these are actually detailed recurrent neural networks and long short-term memory, which is used for word processing. But I won't go in details. I will just say that these are layers. These are used in different layers. So you have sequence of word embeddings that I told you earlier, and we put it through a neural network. Okay, there are layers of neural networks, not just one. And then we put it through a softmax. Softmax is also a logistic regression, but used in a very multi-dimensional form or exponential form. So it's actually logistic regression function only, the somewhat close to the sigmoid function that we were learning. And so the model is now going to predict the next word. So this is basically used, if I give you a half sentence, this is an apple with, so what is going to be the next word after with? So this model actually helps in predicting the next word. It will see the dependencies, and long short-term memory is also closer to recurrent neural network only. But the benefit of long short-term memory is, so what happens is when the model is learning words, right, in the recurrent neural networks. So there's so I start the document where I'm talking about machine learning. So that time it keeps learning and it keeps embedding that, okay, there's one occurrence, second occurrence, third occurrence. But what happens is in the next paragraph, I don't use that word. I start using something else only. I just say deep. So that means that machine learning word is not being used anymore, right? But this model will keep learning that again and again. It will keep putting it in those layers. So sometimes what happens is, even the words that are no more required for prediction or not needed, the model keeps learning the same thing. So to get rid of those dependencies, a long short-term memory was used. What happens is this model keeps looking at the distance between the word which was used last. If the word is not used for a longer time while processing, then it forgets that word. So it releases, it doesn't store that word anymore, and it moves to the next word. What happens is, what we are looking at these boxes right now, but they are actually very huge computation networks, right? So if we build dependencies, then the model also becomes inefficient. It requires a lot of storage space, computation space, and our goal is to actually optimize our models to produce the best accuracy in least time with least computation resources as possible. So we keep refining our networks to do that. Long short-term memory means that it has a short-term memory. It doesn't try to remember a word or something that it has learned over one time for a very long time if it is not required. Okay. So sequential, it can actually explain sequential information very well for that because they are connected. So it will be able to predict the next word or make a final prediction based upon a sequential data. So if I have a data of some person playing a game and choosing one option the other, so this model will be able to remember most of your choices, most of your button clicks, and it will in the end say, okay, this model. So the user will the next move of user will be a left button, not a right button. So this is a very, very simple example, and I think I will conclude here. But as I told you, there are a lot of applications. There are long-term applications. There are short-term applications also. At the very lowest level, if I were to talk about the lowest level, and then we can give very small projects to our students of deep learning. Like this is a very simple example of where we can take an image and we'll say, okay, this is an image database. Can you give us a caption there? And we can also integrate it with the Internet of Things, like the sensors or sensor-based data, and refine our models to make very small daily life application. We can even design some things that can use for reduce manual sequencing or manual labor, traffic light control. A lot of applications are there. I just touched the basics. I didn't go into the models because I believe all of us can read and understand the models very well if we understand the basic underlying factors here. So with this, I would like to conclude and thank you very much. Any comments?
Thank you, ma'am. If any questions? Any questions from participants?
Yeah, madam, how 1D and 2D data affect the accuracy of machine learning?
So 1D data is actually simple because it has a binary classification, but the 2D data can have a multiple classification. So what we try to do is we create filters that we run through those 2D data. So we try to if we have an image, we try to create a filter that can give stronger pixel values, and then those pixel values can again run through the filter and we can get another data. So that is actually, I think the 2D values or 3D values are actually more complicated. They have more coordinates and they need to be they need to be classified with more filters.
Yeah, one more question.
Yeah.
One more question, madam. About the size of data. So in case of
Yes, sir.
machine learning and deep learning, we require huge number of data. So what is the maximum or upper limit by which we can classify?
So there is no upper limit, but yes, if the database has more than 20,000 images, then it will do very, very well. But people work with lesser images also, but just that they have to take care of the overfitting thing. But it should not be less than around about 5,000 images if you want your model to predict decently. So it should be somewhere between 3 to 5,000 images if you're looking only at the image data. So that or observations also, and from 20 to 50,000 is very good if you have a GPU and a cloud setup, cluster setup. Then I think that is sufficient for making good prediction.
Okay, thank you, madam.
Thank you, sir.
Any questions? Participant, would you like to ask any question? No questions? Thank you, ma'am. So nice lecture.
Thank you, sir.
It was
Thank you,
very
sir.
good, well organized and nicely explained. It was
Thank
really
you, sir.
great.
Thank you very much. Thank you, sir.
So with this, ma'am, we will take a break for lunch. And next session will start at 2:30. So enjoy your lunch. Okay, we will meet at 2:30. Sharp at 2:30.
Thank you.
Okay. Thank you, ma'am.
everyone.
Thank you once again.
Thank you.
This conference is no longer being recorded. This conference will now be recorded.
Good afternoon, Pratyush ji.
Good afternoon, sir. Good afternoon.
Are you there, sir?
Haji, sir.
We are again bothering you about this conference.
Haji, sir.
So I hope you will enjoy the lecture.
Haji, sir.
The lecture.
Definitely, sir.
So we already know Pratyush ji.
Yes, sir.
He already presented a lecture in the inaugural of this FDP. So
Yes, sir, yes.
he is again with us with the topic of machine learning in healthcare sector.
Yes, sir.
So I now give the whole power to Pratyush Guleria so that he can present everything. Let me make you presenter.
Yes, sir.
See, sir, I think now you can share the screen.
Yes, sir. I have shared the screen, sir. Sir, screen is viewable, sir.
For me, it is viewable. Participants, is the screen visible? Are you there? Anyone? तो नहीं है क्या हुए?
Sir, voice and screen is clear. I think both the things are clear. I want to check that whether voice and screen are both clear or not.
Voice, your voice is audible and screen is clear. For me, it is audible and clear. But I think it is viewable to all.
I think, sir. I hope so.
Now, let us start the session. They will attend as they come.
Sir, it is visible.
Visible, right? Right, then you can start.
It is visible, sir.
Okay,
Right,
okay.
then
Thank you.
You can start the session.
Shall I start, sir? I should start. I may start now. Okay. Thank you to all of you, and a very good afternoon to all of you. Respected all, I welcome all of you once again for another session on machine learning in healthcare sector. And I hope so. Our previous topic was also connected with the machine learning. We have discussed about the decision trees yesterday. So it was also one of the part of machine learning. It was also one of the part of machine learning technique. So I hope we are going to discuss another aspect of machine learning. Basically, our motive is to discuss the concept of machine learning in healthcare sector only. So I have tried my best to complete many things of machine learning in healthcare sector. So first of all, exactly in previous session, as I was also hearing the previous session, so many of the concepts have been discussed of deep learning also. So that is also correlated with the machine learning. So first of all, what is exactly machine learning is, exactly machine learning, it is the feature, it is one of the emerging technologies which is almost in every sector nowadays. And what exactly is ML? It is basically a set of computer algorithms that improve automatically through experience. So basically in machine learning, as I have earlier told, that it is computer algorithms, but with the help of mathematics, and they used to improve automatically. Whatever we write in a machine, whatever the model we present in the machine, they all improve the machine automatically through experiences. So whatever the machine perform in the future, whatever the events which are going to be done in a future, they will be obtained only through the machine learning, and machine learning improve automatically through experiences. So normally machine learning is everywhere. It may be in aerospace or manufacturing, telecom, healthcare, automotive, and industrial, etc., etc. So some of the areas I have mentioned, in almost in every portion, machine learning is there. But nowadays, machine learning in healthcare sector is taking a boom. Many of the devices are going to become a part of day-to-day life. So that's why machine learning is taking more importance in healthcare sector. Although it is already in many areas which I have highlighted here. So these are some of the fields which are already working on machine learning, and they are getting the output of the machine learning from such fields like aerospace, manufacturing, telecom, industrial automation is there, then maximum car automation is there, then driverless vehicles are there, which are automatic vehicles in which there is no need of drivers. So auto detection features are also there. So that is one of the part of it. Then exactly what is the machine learning workflow? First of all, in case of machine learning workflow, we access and explore the data. First thing is, the foremost thing is to have the data. First, we need data, and that is called training data. And that I have earlier told, and in another session, it has also been mentioned that training data is the most important thing, because we need the training data in the form of Excel files. It can be in the form of .csv files, or it can be in any form like SQL servers are there, or another files are there. So first of all, we have to access and explore the data. Then we need to pre-process the data. Now this term is very important, that what is the meaning of pre-processing. So pre-processing, exactly I will discuss in detail in the tomorrow's lecture also, but pre-process means when we remove some missing values, when the data, some features are being extracted, some attributes are also selected, and sometimes the data which we obtained through the internet resources or in the public domain are little bit messy. Some values are missing there, some columns are missing, some fields are not properly written, the data types are also not properly clear. But whatever the data we got, that we have to pre-process that data, because data pre-processing is urgent for getting the right output for machine learning. Otherwise, without the proper pre-processing of data, it is very, very tough to get the right output. And mainly in case of healthcare sector, it is very urgent, or it is very, very important to get the right kind of data, because if you get the wrong data of the patient, then it may result into a serious consequences. So pre-processing of the data is very necessary, mainly in such cases of healthcare sector. Then after pre-processing the data, we have to develop the predictive models. Now, what are predictive models? Predictive models may be any kind of machine learning algorithms. Either it may be decision tree, either it may be support vector machines, either it may be k nearest neighbors, either it may be any clustering techniques, either it may be any reinforcement techniques, which we have discussed in another sessions by some of the experts yesterday. So there are many predictive models which used to be developed on this data only. So first of all, I want to give you one thing idea, that if we are working in a healthcare sector, then foremost thing is that we need to achieve the data. We have to get the right data from the healthcare or medical sciences, and only then we can prepare or develop the predictive models and then integrate those documents with the systems. Because the final thing is we have to integrate them with the system softwares, or it may be application softwares, like there are some enterprise systems, C, Java, or any other languages, or any embedded hardware devices are there. So for that, we have to connect it. Because the techniques nowadays, there is more and more discussions on IoT type fields, which is known as Internet of Things. So IoT basically requires such type of predictive models. So in case of IoT, you need to integrate the systems, you need to integrate the applications with the system, but it can be only done when you have the proper predictive models. Only then IoT like fields can come into the scenario. Now, what is the machine learning network workflow? In machine learning network workflow, first of all, you have to load the pre-trained network. Basically, you have to carefully understand the concept between the previous slide and this slide. In the previous slide, it was machine learning workflow, but in present slide, it is machine learning network workflow. So in some cases, like neural network, why I am saying neural network? Because in such type of cases like neural network or convolutional neural networks, you need to train the network. because in another machine learning environments there is no need of training the network. But when you are working with the neural sciences or fuzzy logic type activities or any deep learning type activities, in such cases you need pre-trained networks where the networks are already trained, and then we have some classes or target data sets are there, and on those target data set we again train the network so as to achieve the right output. Because machine learning, when working with the network workflow, requires the image analysis. The major focus of machine learning network workflow is on image analysis. So when you have to train the images, so there is need of pre-trained networks. पहले से ही आपके पास एक pre-trained network is must, and only then you can train that network to get the right kind of output at the end. So at the end you need a trained network, but for that you have to make it learn again and again. You need to load the pre-trained networks. Okay. Then comes machine learning algorithms. Whatever I have mentioned in this figure, they all are machine learning algorithms, starting from linear regression to naive Bayes and support vector machines, k-means, random forest, and etc. etc. All these are machine learning algorithm, or you can say that these are the models which we have to embed in any type of programming language. आपके पास programming language is already there are programming language like Pythons है, R programming है, MATLAB है, or otherwise more and more some more programming like Julia is one of the language also which is being used in some cases. So there are a lot of programming languages, but they need some machine learning algorithms, and moreover these machine learning algorithms come in the form of some libraries. As you already understand that libraries are basically what, like in Java or in other languages, if we have to use some pre-trained networks or if we have to use some pre-trained features, so in that case we need already we have to obtain what? We need some predetermined libraries. So libraries are basically inbuilt libraries, and inbuilt libraries basically are obtained through machine learning algorithms. So here basically the concept is that machine learning algorithms are already there, but they have to be in the form of libraries, and these libraries will come in Python and R programming. That's why these are the algorithms which are very important. Now the type of machine learning, as I have already told, so इसमें ज़्यादा हम इस वाली slide पे focus करने की आवश्यकता नहीं है, because these type of machine learning consist of the supervised learning, which we have earlier discussed. And in supervised learning, basically we do the predictive models. We use to run the predictive models consists of we have input and output data, both in case of predictive model. But what are the categories of algorithm which is implemented into it? That is, one is regression, second one is classification that we have discussed yesterday. Okay. Then comes, like in this slide, I have written the objective that easy and accurate loading is required, accurate forecasting is required. So for that purpose, such type of algorithm, the algorithm which will be implemented in this case is of regression. Here we will implement the regression algorithm, because in regression, I earlier told that we have the variables, x and y are the variables, and the outcome will be in the form of z. So here the objective is to achieve the system forecasting or the system load in a regular manner. So such case, we need a regression algorithm. We do not require classification algorithm here, because we have to find out the forecasting value. So here we have a regression algorithm. Now comes that artificial intelligence is the starting point, and artificial intelligence is the base class, and machine learning is being derived from the artificial intelligence, and then deep learning is the time of today, where many fields are working on the deep learning, and deep learning are nothing but the neural networks and basically neurons point of view. The work is going on the neural networks, and machine learning is basically derived from artificial intelligence, and deep learning is derived from the machine learning. So basically all these are the fields which are required for today's time. Machine learning is there, then deep learning is there, then reinforcement learning, predictive maintenance, data science, signal processing, image processing, etc., etc. But artificial intelligence was the starting point. But when there is little bit advancement, then it comes to machine learning, and finally, when it is more and more advancement going on, then it comes to deep learning. So artificial intelligence was the early artificial intelligence stirs excitement. It was in the starting when there is a robotics technology, but at that time, what you input, what you get. What we fed into the machine, we get the output of it, but we don't have the knowledge. Inference is not there, knowledge understanding is not there. There is no need to understand from the past events. So such type of things comes into machine learning, because machine learning get the knowledge, get the learning from the past events. So artificial intelligence was like you put some value and you get some output. Like in artificial intelligence, Prolog was the language for artificial intelligence, and in Prolog what we do, that there are certain events are there and we get the goal, and there are certain alpha and beta proning features are there, then we get some hill climbing features are there, then we have the searching engine is there. So such type of things are the part of artificial intelligence. But when it comes to learn the things, learns the event from the past features, then it comes to machine learning. And finally, it comes to deep learning, when you work upon some neural type of sciences, when you work upon the nervous type of systems. And in nervous system, you need a lot of hidden layers are there. We calculate the hidden layers, we get some inputs, we get the outputs, perceptrons are there, then multi-layer perceptron values are there. So such type of things comes into deep learning. And today's time, the major focus of deep learning is only on the image processing, because image processing is the part where deep learning is flourishing a lot nowadays. Now, exactly how deep learning is connected with the machine learning? As I already told, that deep learning is being derived from the machine learning. So there is an interrelationship between the machine learning and a deep learning. But in case of deep learning, it is basically the automatic feature extraction. Like in the picture, you can see properly that there is a picture of a car and you have some learned features, and learned features means what? The learned features means CNN. And what is CNN? CNN means convolutional neural network, because I have earlier told that deep learning is basically concerned with the convolutional neural networks, because these are the parts, these are the things which are connected to it. So here it is a picture of a vehicle, but now we have to find out with the help of the deep learning that what this picture is exactly about. So there may be chances that you get the right result. There may be chances that you may get the wrong result also. But what if machine is successfully able to understand the previous and the past events in a proper manner? Only then deep learning is successful, and then only it gets the right output. Otherwise, there may be chances that result may be biased, result may be fake. So first of all, the thing is that you have to train the network in a such manner that every time when you give some another input to it, then machine automatically understand and automatically give the accuracy that how much clarity of the vehicle is there. That is called deep learning. Because in machine learning, there may be chances that you can get the wrong output also. There may be chances that you get the overfitting of the output. But when you talk about the deep learning, then here the concept is that you have to train the network regularly, so that when you put some another input into it, then it automatically detects that whether the vehicle is a car or any another thing. Like here we have used a pre-trained model is there. So as picture is very clear that there is a dog picture, but without proper networking, without proper pre-trained model, what happens that machine automatically detect it as a cat, which is a wrong answer. Why? Because I have earlier told you that for deep learning, it is very, very required that the network should be trained properly. You need a lot of data. That is the major difference between a machine learning and a deep learning. That in case of deep learning, you need a huge amount of data. Only then you can directly talk about the right output. Otherwise, there may be chances that in absence of the proper data, the output may be wrong. Like in such case, you have put the image, you have fed the image of a dog, but what happens that without proper training, the convolutional neural network give the output of a cat, which is wrong. But when you transfer the learning, when you modify it, and when you train the network again and again, when you increase the weight of images, then what happens? The network understands that this is basically not a cat, it's a dog. So that is the basic fundamental of deep learning. Now again, what is machine learning versus deep learning? That is, deep learning perform end-to-end learning by learning features, representations from images, text, sound, etc., etc., etc. So basically we have to identify. So basically in deep learning, again, in case of deep learning, what is happening? We are obtaining the picture of a vehicle and we are getting the right output. And in an earlier session, when I was also hearing the previous session, there was one example of MNIST data set which was provided by the speaker. Then the MNIST data set was basically related to the digital handwriting. So in that data set, if the input is properly given and if the network is properly trained, only then machine learning algorithm can easily detect that what number you have fed into the machine. If you have written 6, only then it can identify the image properly, if provided you have given the right kind of machine learning, you have properly trained the network, only then it can identify the right output. Now, what is the basic difference between a machine learning and a deep learning? In case of that, training data set is very small. In case of machine learning, it may be small, but in case of deep learning, the training data set should be large. It should be huge. Choose your own features. In machine learning, you can choose your own features. You can synthesize the data set. आप अपनी तरफ से data set बना सकते हैं. You can create your own data set. But in case of deep learning, you need not to take your own features. You can't take your own features. You have to take only those features which are in real or real time are being used. Only then it is successful. Now, number of classifiers available. There are many number of classifiers available in case of machine learning. As I earlier provided the picture in which there were a lot of classifiers. Classifiers means algorithms. So there can be nearest neighbors is there, naive Bayes algorithm is there, decision trees are there, then support vector machines are there, and many other algorithms are also there. But in case of deep learning, the number of classifiers are very few. It is basically dependent upon the neural network. It is basically dependent upon the nervous system. It is basically dependent upon the convolutional neural network, or you can say here we definitely use the perceptron. We use the back propagation algorithms are being used. So here the algorithms are very few comparative to the machine learning. Now, what is the training time of machine learning? The training time in case of machine learning is very short. You easily get the output. When you run the programs of machine learning, you easily get the time, easily get the output, sorry, in a very short duration of time. But when it comes to deep learning, the time duration is very long. You have to wait for a time, and only then you can get the output. And sometimes it may also happen that system get hanged. So there are chances of it. So that is the basic difference between a machine learning and a deep learning. Sometimes many images are not being properly shown. That what is the difference between. Many people are not very much clear about the machine learning and the deep learning difference. But these are the concrete differences of machine learning and the deep learning. Now, what is the machine learning classification workflow? First of all, in machine learning classification workflow, as I have earlier mentioned, and in many resources, you also obtain the thing that we have to import the data. Then in the second stage, we have to organize and pre-process the data. Then we explore that data. Then we build the model, evaluate that model, and finally deploy the model for use. So first of all, we have to import the data. That is the foremost thing. That is called training data set. That is the most important thing. Then we have to organize and pre-process data. हमें organize करना है. We have to remove the missing values. We have to remove the outliers. Outliers are called the missing values. Then we need to explore that data. Explore that data means we have to extract some features from it. We have to arrange them. We have to convert some categorical values into numerical values. जैसे yes or no है, तो we have to convert it into 0 or 1 like form. Then we build some models. Then we evaluate that particular model. Evaluate means we validate that model so as to finally deploy that model for final use. Now, what is exactly learning and machine? Because we are saying machine learning in healthcare sector, so first of all, we have to be very much clear about what is exactly learning and machine. Exactly, machine is the algorithms or the mathematical equations that are put into a machine. And we put these equation in the form of program. What we write in a C program or what we write in a C++ or in Java or any other language, we are writing what? We are writing some algorithm, we are writing some machine learning algorithm, or you can say we are writing some mathematical formulas of standard deviation, regression, or any chi-square method or any other methods we used to write. And those methods are then learned by the machines regularly by having some experiences so as to get the desired result. So as the picture depicts, what the slides shows that machine learning, then support vector machines, the major thing in support vector machine that there are only chances of two hyperplanes, only two classes are there, that is yes or no. Then when we come to the k nearest neighbors, then we find out the nearest position, and nearest position can be obtained through Euclidean distance is there, then Manhattan distance is there, Manoblis system is there. Then Naive Bayes is basically what probabilistic algorithm is Naive Bayes. Then discriminant analysis is there, then decision tree as I have earlier discussed in the previous session. So all these are the classification workflows. Now, how machine learning is implemented in healthcare sector, and as an initial stage, as a practically how we implement it in the healthcare sector. So basically in healthcare sector, better imaging is there, diagnostic techniques are there. We are detecting the disease, we can detect the disease in the earlier stages on the basis of the symptoms obtained and the diagnosis by the doctor. We have the clinical decision support systems are there. We have drug discovery and research, preventive measures are there. But it is also one of the things that we are saying that machine learning is implemented in healthcare sector. But apart from all these things, it is very unfortunate that we don't have the proper vaccination of COVID nowadays, as we are talking about machine learning in healthcare sector. But still, after almost 1 year, we don't have the proper vaccination or the medicine of prevention of COVID. That is again unfortunate. That is another part of this thing. But in healthcare sector, still very many things are being done. And for detecting the disease at earlier stages, drug discovery research is there, and all these things are connected with the IoT, that is called Internet of Things. And Internet of Things is basically being used as many of the people used to wear the watches in their hand, and those watches are directly connected with some output messages. In those watches, we get the heartbeats is there. One feature of heartbeat is there. Then sugar detection is at not present, but in near future there may be chances that you can detect the sugar value on the basis of that wristwatch, which consists the many features of machine learning. So there are a lot of things which are being done in machine learning for healthcare sector. Now, how MRI images are being detected? This is the frontier part of the machine learning which is being used. Using the biological neural network, or you can say computer neural networks, using the hidden images or artificial neural networks, the image analysis is being pursued. So basically, classifying the MRI images is basically you use the transfer learning to leverage a predetermined trained model to classify the MRI images. We visualize the occupational maps. So it is completely, as I've earlier told, that these are the part of deep learning. Here the work of research is going on, that how to detect, like here the image itself is explaining that image is getting the reception of some receptor of a cat, and that image further passes through many neural nervous systems so as to respond the value of cat. So all this is known as convolutional neural networks. From that we are obtaining the output of it. That is one part of MRI imaging, and many of the advancement is on the go or for the healthcare sector in using machine learning. Then these are some of the sectors of AI and healthcare, in which it consists of brain-computer interfaces is there, AI-based radiological tools are there, and EHR. EHR means electronic health records using AI techniques. So at first, that is brain-computer interfaces, it is already there, and many of the work is already undergoing in this part, because brain computer interfaces are being implemented for those people where there is kind of nervous problem is there. They are not able to interact in a normal manner. So in such cases, machine learning and BCI, that is called brain computer interfaces devices, are discovered for proper communication. Whereas AI based radiological tools consist of, radiological tools means nowadays many radiological tools are being developed, but sometimes there may be chances that they don't provide the accurate prediction or they are unable to cluster something. Suppose जैसे radiological tools की help से you can easily detect that which portion of the body is not working or where there are chances of some infections, but that is also a part of prediction. So if you don't have the proper artificial intelligence based radiological tools, there may be chances that you are getting the wrong prediction. So in such case, artificial intelligence is again very important. Electronic health records means electronic health record using AI technique consists of what? Using EHR, we are basically identifying the infectious patterns and highlights the patient condition at risk. And normally, it is also one of the scenario, maximum cases, in maximum cases, like if any patient go for IGMC, then that particular patient has to pass through all type of tests for finding out the final diagnosis. And when that patient again go for a further particular अपने purpose के लिए, that further उसके लिए जा रहा है hospitalization के लिए for PGI, then again that particular patient has to pass through all those tests again. Here there is need of such type of research, that here the patient electronic health record is completely already maintained, so that patient have to directly get diagnosis from the doctor and he get away from the hurdles of again and again getting the test of it. So in such cases EHR is required, and here EHI is connected with the IoT. जो बेसिकली रिसर्च है वो इलेक्ट्रॉनिक हेल्थ रिकॉर्ड्स पे बहुत हो रही है, और उसका कारण ही ये है बिकॉज इलेक्ट्रॉनिक हेल्थ रिकॉर्ड अगर पेशेंट का होगा, सो ही विल गेट सम डिवाइस, RFID डिवाइस उसको एक मिलेगी, सो दैट कि जब पेशेंट IGMC में ऑलरेडी वो टेस्ट करवा चुका है किसी डिजीज के, सो व्हेन ही मूव टू PGI और सम अदर हायर स्पेशलाइजेशन, तो वहां पर अगेन उसे वो टेस्ट ना कराने पड़े, सो दैट वो डायरेक्टली अपने उस डिवाइस के बेसिस पे जो डेटा है उसका वो डायरेक्टली डॉक्टर के पास आइडेंटिफाई हो जाए कि ये टेस्ट ऑलरेडी हो चुके हैं, सो दैट पेशेंट को फिर से टेस्ट कराने की आवश्यकता नहीं है. वहां पर इलेक्ट्रॉनिक हेल्थ रिकॉर्ड्स की भी जरूरत है, एंड IoT is also required at that place, because without internet, without sensors, we cannot identify the position of a patient, and for that purpose we need IoT devices, ताकि वो सेंस कर सके बॉडी को और बता सके डॉक्टर को कि दिस वाज द प्रिलिमिनरी रिपोर्ट ऑफ द पेशेंट, सो पेशेंट हैव टू डायरेक्टली गेट द एमरजेंट डायग्नोसिस एट द राइट मैनर. अदरवाइज पेशेंट को पूरा फिर से फॉलो करना पड़ेगा वही सिस्टम, सो ही मे नॉट गेट द प्रॉपर राइट डायग्नोसिस एट द राइट टाइम. सो फॉर प्रिलिमिनरी इन्वेस्टिगेशन इलेक्ट्रॉनिक हेल्थ रिकॉर्ड इज वेरी वेरी रिक्वायर्ड. Then comes AI assisted radiology and pathology. Now electronically stored medical images and algorithms are required to detect and discover patterns. Now here the concept comes of what? Now here the concept comes clustering. Here the concept comes of pattern recognition, because here pattern recognition is very very important, because we used to find out the cluster, we used to find out the patterns, or that what will be the pattern, because here unsupervised learning will be coming to. Here the supervised learning is not there, and here we will get the unsupervised learning. So that is the concept of this clustering, that is called pattern recognition. So that is very very important. Then comes that machine and algorithms can interpret the imaging data with the help of skin lesions, tumors and bleeds. So these all are at later stages. These are very in advanced stages and required very importantly. So these are for clustering, that is called unsupervised learning. Then finally comes identifying the rare or difficult to diagnose disease depends upon detecting the so-called edge cases. But here the major thing is that we need what? We need large data sets we need large data sets containing some values, transformations of these diseases are required. So we need large databases, large data sets are required at this stage, because large data sets are required. Why we need the large data sets? Because for getting the accurate results, results in the form of images, we need large data set. हमें थोड़े ज़्यादा बड़े large volume के data sets की requirement है, because machine learning so that की output जो है वो आपकी accurate and precise आ सके, prediction proper हो सके. Then physical robots for surgery assistance. Now, what is physical robots for surgery assistance? Physical robots for surgery assistance consists of what? Virtual reality is the major thing which is providing a boon to the artificial intelligence, because artificial intelligence is requiring virtual reality space for real-time detection and guidance. So what happens into it? Like in images, what is happening that basically the doctors hai, they have weared what? They have weared some virtual reality devices. They have weared some 3D devices so as to get the right kind of image, so as to get the precise image. So for that, we need physical robots for surgery assistance, because such type of thing is come under distributed processing. Here, at one place, many people are working, many people are going to have the records. Then telemedicine is also one part, but telemedicine is also part of today's life also. Many people get the appointment from the doctor, and directly from doctor they are getting the advice. That is a sort of advice that is called telemedicine. So all these comes into with the help of machine learning. But the thing is that whatever is basically diagnosed in case of medical sciences, that need to be recorded in the form of data set, so that further research can also be undertaken for another machine learning purpose. Precise analytics for pathological issues. Maximum cases में जो normally concept है कि जो decisions healthcare में लिए जा रहे हैं, somewhere 70 and 75% of the data in electronic health record are from the results. But the thing is, पैथोलॉजी के बहुत से रिजल्ट्स मैक्सिमम केसेस में जो रिपोर्ट्स देखने के बाद ही द डॉक्टर इज बेसिकली डायग्नोजिंग द पेशेंट. बट द मेजर प्रॉब्लम इज कि कई केसेस में क्या है कि जो डाटा है वो बिल्कुल सही होना चाहिए, इट शुड बी वेरी मच एक्यूरेट. और एक्यूरेसी को इंक्रीज करने के लिए ही nowadays a lot of research is undergoing on electronic health record. That's why I have highlighted this particular thing, electronic health record, क्योंकि न्यूरल नेटवर्क एक पार्ट है, प्रैक्टिकली काम हो रहा है, पर कहाँ हो रहा है ज्यादा हमें पता नहीं. लेकिन इलेक्ट्रॉनिक हेल्थ रिकॉर्ड्स का कंसेप्ट क्या है कि इसमें नॉर्मली जो डाटा है, सारा काम ही डाटा का है. whatever the data you collect, that data is again experimented with different machine learning algorithms so as to get the right output, so as to get the accurate output. और इसी के बेसिस पे फिर आपका IoT डिवाइसेस भी काम करते हैं. IoT दैट इज इंटरनेट ऑफ थिंग जो डिवाइसेस हैं वो भी EHR के बेसिस पे ही काम कर पाएंगी. कि किसी भी पेशेंट की आउटपुट अगर उसकी डाटा के फॉर्म में अवेलेबल होगी, हमें इलेक्ट्रॉनिक हेल्थ रिकॉर्ड के फॉर्म में अगर अवेलेबल होगी, तो ही वो जो डिवाइसेस बनाई जा रही हैं, जैसे लोग रिस्ट वॉचेस खरीदते हैं, ब्लड प्रेशर डिटेक्शन की डिवाइसेस खरीदते हैं, सो दैट only then that can be monitored. Now, bringing intelligence to medical devices and machines. In the medical environment, smart devices are critical for monitoring the things that I have earlier stated, that ki bahut se log they are used to wear the wrist watches and other things for blood pressure detection, many things, but still these things are very limited, and maximum research is further undergoing on right kind of tools are required, right kind of devices are required, right kind of data set is required. मैक्सिमम केसेस में तो मशीन लर्निंग में आपको डाटा सेट ही सही तरीके के नहीं मिल पाएंगे. और अगर आप आज की डेट में भी किसी चीज पे एक्सपेरिमेंट, इफ यू आर गोइंग टू डू सम मशीन लर्निंग ऑन हेल्थ केयर सेक्टर, तो डाटा सेट ही सबसे ज्यादा इंपॉर्टेंट है. और आपको इतनी आसानी से कोई भी मेडिकल हॉस्पिटल आपको वो डाटा प्रोवाइड ही नहीं कर पाएगा, बिकॉज या तो वो प्रोवाइड करेगा तो जो डाटा है that may be not be in a proper form, it may be unstructured form, so that need to be in a structured form. तो वो सारा डाटा it should be in a structured form. Then comes the advancing the use of immunotherapy for cancer treatments. This is also one aspect of machine learning nowadays, because in nowadays what is happening that as such we know that cancer treatments जो हैं later stages में it may be very fatal, or there is very risk of at the later stages, but we can identify or we can reduce the chances of fatal at the later if we detect the cancer devices in the initial stages. But again, the concept is that you need highly complex data sets are required, which can be used for targeting the therapies. आपको therapy अगर करनी है, then you need some highly complex data sets from where we get derive the results कि उसके कुछ output सही आए भी हैं कि नहीं आए. So that is again one part of it. Now, please focus on that underlined lines, that we need structured and unstructured inputs are there, because whatever the data in medical sciences is available on the public domain they consist of data, but maximum data is not in a proper format, that is in unstructured format. Some cases there is a PDF files, in some cases it is text files, in some cases it is only images. So the major task is to convert all that data set into a structured and a meaningful format so as to achieve the clinical decision support and predictive analytics. Otherwise, it is very, very tough to get any particular results. That is why I am again and again focusing on EHR, because nowadays the thing which is undergoing is on EHR, and rest of the things like deep learning, etc., they are a part of it. But in practically I am unable to say कि कहाँ पर implement हो रही है और किधर जो है लोग उसको practically हम देख पा रहे हैं कि कहाँ use हो रहा है. But electronic health record is the part where people are really working on it. Like जैसे कोविड का आजकल है चला हुआ, तो कोविड का डाटा सेट आपको इंटरनेट पे मिलेगा पब्लिक डोमेन में. Many people are working over the data set. They are putting that data set, they are passing that data set through a machine learning algorithm so as to get the right kind of accuracy, to get the right accurate results and predictive results that what the patient is going from. So predictive analytics के लिए you need some structured kind of data. Then monitoring the health through wearable and personal devices. In artificial intelligence, the wrist watches the people are purchasing, the heartbeat which is calculated, the blood pressure devices are there. They all are the part of machine learning, because we are monitoring our health wearable devices. But again, the concept is that that particular thing is only up to two things that we have seen in a day-to-day life. Like आप ज्यादा से ज्यादा अपना हार्ट बीट चेक कर लोगे, ज्यादा से ज्यादा आप क्या कर सकते हैं अपनी रिस्ट वॉचेस के बेसिस पे, यू कैन चेक योर हार्ट बीट. बट अबाउट बियॉन्ड दैट क्या है? बियॉन्ड दैट ऐसा तो नहीं है कि आपने उस रिस्ट वॉच के ऊपर क्लिक किया और इमीडिएटली आपकी जो इन्फॉर्मेशन है वो किसी डॉक्टर के पास चले जाए कि दैट द पेशेंट इज एट द रिस्क, और उसको इमीडिएटली कोई प्रिलिमिनरी जो है मेडिसिन मिल जाए सो दैट कि वो बच सके. So such things are undergoing. So वो part electronic health record का ही है, that where this type of thing is going to come in a few months or in years, कि आपकी जो wrist watches हैं उसी से आपका जो data है वो collect हो जाएगा, and the nearest जो भी डॉक्टर आपके hospitals हैं they will be on a track for it, and you can easily identify whenever the patient is at risk. तो आप अचानक directly उसके साथ connect कर सकते हैं. Like then again making the smartphone selfies. जो स्मार्टफोन सेल्फीज हैं दे आर ऑल्सो बिकमिंग द पार्ट ऑफ डायग्नोस्टिक, बिकॉज जो सेल्फीज हैं कई मोबाइल्स में देयर इज अ वेरी क्लियर पिक्चर्स आर देयर, वेरी क्लियर इमेजेस आर देयर, एंड फ्रॉम दैट इमेजेस वी कैन इजीली फाइंड आउट कि कहाँ पर मतलब आपकी क्लैरिटी जब तक इमेज की नहीं होगी, वी कैन नॉट आइडेंटिफाई द क्लस्टर्स, वी कैन नॉट आइडेंटिफाई द क्लासिफिकेशन ऑफ द इमेज. एट दैट पॉइंट इफ स्मार्टफोन सेल्फीज कैन बी बिकम द पार्ट ऑफ diagnostic, that can become the part of discovery of medical sciences also. Now, what are the utilities of machine learning techniques? These all are the utilities of machine learning techniques. Almost all techniques are covered under these things. Like supervised learning, classification is there. In classification, what things are in classification? Fraud detection is there, email detection, diagnostic, image classification, etc. Then in unsupervised learning, we have image recognition is there, face recognition, text mining. टेक्स्ट माइनिंग भी एक आजकल बहुत ज्यादा पार्ट चल रहा है अनसुपरवाइज्ड लर्निंग का, जिसमें कि वी कैन फाइंड आउट, वी कैन माइन द टेक्स्ट. एक उसको भी आप हेल्थ केयर के साथ ट्राई कर सकते हैं. सपोज यू हैव अ डेटा सेट जहां पर बहुत सारी मतलब आपके पेशेंट के जो डिजीज हैं और पेशेंट के जो सिम्टम्स हैं वो लिखे गए हैं, एंड फ्रॉम दो सिम्टम्स यू आर आइडेंटिफाइज स्पेसिफिकली सम सिम्टम्स, एंड दैट कैन हैपन ओनली थ्रू टेक्स्ट माइनिंग. तो ये भी एक पार्ट इसका काफी ज्यादा आजकल हेल्थ केयर सेक्टर में है. देन कम्स रीइंफोर्समेंट लर्निंग, जो कि आपने कल भी हमने डिस्कस की थी एट प्रीवियस स्लाइड में. जो और स्पीकर्स थे, दे हैव डिस्कस्ड अबाउट द रीइंफोर्समेंट लर्निंग एंड सम मॉडल्स दे हैव डिस्कस्ड. सो दैट इज द पार्ट ऑफ रीइंफोर्समेंट लर्निंग. नाउ completely in machine learning techniques, it is completely based upon the training data and the test data. So you have to remember the thing that in training data we need some data which we have to train again and again. But why we have to test that data? That is basically required for model validation. We have to validate that data, because only on the basis of training the data and getting the output, that is cannot be the right kind of data science analytics. You need to test that data, you have to validate that data. Suppose if you have a data set, then you have to convert that data set into 80% and 30% or 80% or 20%. Like आपने 70% data जो है आपने training के लिए रखा है, then you have to keep 30% data for what? For testing purpose, so as to validate that particular record, so as to validate that model. Now, what are the uses of machine learning? Better decision making, predictive analytics, that what will be the next, and pattern discovery. Pattern discovery means hidden information, and hidden information again it is the part of healthcare. Like मैंने आपको जैसे images बताई थी, that if there is some scanned images are there, then MRI images are there, then sometimes it is very tough. कई बार कई लोग क्या करते हैं, CT scan कर रहे हैं, MRI क्यों करवाते हैं? So that कि they get the precise result of it. क्योंकि कई बार chances रहते हैं कि clotting हुई है कि नहीं हुई है, किसी तरीके की हेमरेज में कि नहीं हुई है, तो उस केस में you need MRI images. So such type of pattern discovery is the part of machine learning also, or in that case you need such kind of images which are very, very clear. That is why I discussed in the previous slide that mobile selfies are also becoming the part of it, because in mobile selfies the camera is very much powerful in some mobiles. So that is again very important thing. Then comes what is the medical data. All these are the part of medical data. We examine the patient, inpatient health monitoring is there, medical imaging is there, laboratory results are there, then patient health care is one part of it. So all are the uses of machine learning in medical data. Now, from where you get the data set for machine learning or healthcare data set, I have quoted this particular URL from where you can directly download the data sets of medical sciences. Many blood pressure data sets are available there, then diabetes data set is there, and some recent data sets are being provided by some of the researchers into it. Then Kaggle is also one of the website from where you can get the data. But जो मुझे पर्सनली लगता है कि UCI मशीन लर्निंग से जो है आपके डाटा सेट बहुत अच्छे हैं, उसमें कई डाटा सेट काफी मतलब प्री प्रोसेसिंग की जरूरत नहीं रहती है, उनको काफी हद तक जो है वहां पर मिसिंग वैल्यूज हटाई गई हैं. तो आई थिंक दिस इज वन ऑफ द good data sets for machine learning. Now suppose this is that machine learning model. We are having two variables, एक weight है, एक price है. अब how to identify it? How we can identify them? So उसके लिए what we are doing, we are converting that weight and price on some algorithm. कि अगर weight जो है वो इतने से ज्यादा हो सकता है तो price ये रहेगी, otherwise price ये रहेगी. That is again if and then we are using. So that is one aspect कि हमारे पास ये machine learning एक model है जिसमें कि we are finding what? Classification model is the division of feature space into region space. हमारे पास एक label है that is called the output category. Output category means the class, that is outcome that is called predicted value. So we are training some value so as to get the right result. Now what is machine learning model? All algorithms, all equations of mathematics, whatever the formulas are there, they all are part of machine learning models. Now this particular model is to be implemented what? With the programming. And then we classify our result into two parts. That's why we have clustered it into two parts. कि एक तरफ हमने कहा कि ये दो cluster we have made. अब इसी तरीके से we can think कि अगर यहाँ images हो तो we can again cluster them. हम उन images को भी cluster कर सकते हैं. We can cluster the images also, right? The machine learning training and tested model. Now why training and tested model is required? अगर ये कोई और data set होते तो मैं ये कहता कि there is no need of testing. कोई बात नहीं, ठीक results भी आ जाएंगे. There may be chances of predictive results, but when it comes into the case of healthcare data set, then I will always suggest that you need to train and test the model properly, because these data sets are require a lot of pre-processing so as to get the concrete results. But suppose here for this example there are two predictor variables and we have the two output classes. Now if the price is greater than the weight, then use symbol star else circle. तो अब ये जो पिक्चर आप देख रहे हैं, फिगर देख रहे हैं, तो इसमें जो लाइन एक बीच में लगी है, आप यू कैन से दैट इट इज अ पार्ट ऑफ सपोर्ट वेक्टर मशीन, बिकॉज सपोर्ट वेक्टर मशीन जो एल्गोरिथम मशीन लर्निंग का है, इट कंसिस्ट ऑफ ओनली 2 टाइप ऑफ क्लासेस, दैट अगर आपकी प्राइस जो